Hi, this is the second part of the video on molecular shape. We left off with talking about, where'd it go? Hmm, Actually, we left off right here. I know it's not filled out right now. We were in the middle of, looking at sp3 hybridization and looking at the fluorine as being the central atom. There would be one bonding area, three non-bonding areas, and then we would say this is AB1E3. So now we're going to talk about sp2 hybridization. So here is what's going on, and boron does this, and boron is an exception to the octet rule. So normal boron, we would have the 1s2, 2s2, and then 2p1. But what really happens is one of the s electrons jumps into the p orbitals, and then the s and the p orbitals combine. So you can see that we're going to have a total of 3 bonding or non-bonding lone pairs around the central atom. So let me show you. So for example, what we're going to see here is we're going to have that central atom with 3 other atoms bonded. The angle is now 120, so this is different than a trig pyramid. There's no lone pair. So example, and I'm not trying to show the angles at all here, but boron will do this, and this is an exception to the octet rule. It's good with just 6 valence. Because you know that the chlorine, all of the halogens can't double bond anyways. And so if you look at the boron, there's 3 bonds, no lone pairs. So this would be AB3. So this adds up to 3, which would mean it's sp2 hybridization. There's 3 hybrid orbitals. There's also a bent for sp2 hybridization. It would have a central atom. Again, so the difference between this bent and the sp3 hybridization is you only have 1 lone pair of electrons on the top. Example of this. So if we look at the nitrogen in the middle, you can see that there's 2 bonding areas. So we do count that double bond only as 1 bonding area. So there's 2 bonding areas, and then there's that 1 lone pair on the top, which still adds to 3. So 3 orbitals would be sp2. So we call this AB2E1. Linear, again, this is a 2-atom linear. If you look at this as my central atom, you can see that it has 1 bonding area and it has 2 lone pairs. So example O2, you just have to pick one of them as your central atom. So if I pick this oxygen, you can see that it has 1 bonding area, 2 non-bonding lone pairs, so it would be AB1E2. And lastly, we have sp hybridization, and this is when you're going to have really 2 hybrid orbitals. So you'll have a total of 2 bonding areas or a combination of, I think you're just going to have 2 bonding areas for these. So you would have a central atom with 2 atoms coming around it. So no lone pairs on the central atom. So it could be, double bonds, but again, those are just 2 bonding areas. Could be a triple, but still 2 bonding areas, no lone pairs. Example, beryllium is also another exception to the octet rule. It's a metal, but it bonds covalently. And you can see it's going to be linear. There's 2 bonds around the beryllium, so beryllium is okay with 4 valence electrons instead of 8. And another example, so this is sp hybridization. Up above we had sp2. Another example is carbon dioxide. Again, we only count those double bonds as 1 bonding area. So, and notice there's no lone pairs around the central atom, AB2.